All right, so today we're going to look at just a few more. Now we're going to get into some of your sine and cosine, a little bit of the trig stuff, so that that's still fresh in your mind. Because again, if we're going to go into college and we're going to go and take some calculus, you will definitely go and see some of these trig guys. So make sure you have the basic rules and then also the ones that involve sine, cosine, secant, making sure that you know those as well. So we're going to look at that today. So we'll just get started with that. If I go look at the first one, again, I have two x's. Well, I can go and rewrite this. This is really x times x to the 1/3. So again, that's just going to say this is really x to the first, so 3/3. And if I add those together, that's going to make that to the 4/3. So before I go and do anything, I'm going to go and add 1. So again, take the bottom number, that 3 is going to be added to the top, so 7/3, and then make sure I go and multiply by the reciprocal. And then again, this is my true antiderivative, right? The plus c, that's important. But with these, when we're evaluating, okay, which again is different because they actually give me a stop and a start value, I need to go and plug in. So if I go and look at 27 and I go and look at -1. So again, subtract where I stop minus where I start. So if I take 27 and I go and plug that in, and today I'm going to use a little bit cheating here, but 27, the cube root would be 3. So I have 3 to the 7th, right, times another one. So this is really 3 to the 8th power. But again, my calculator would go and do that for me, and then divide by 7. That goes and gives me a crazy decimal, so it's going to be 65. 61 divided by 7. And then if I go and plug in -1, well, that's going to say take the cube root of -1, which is still going to be -1 to the 7th power, still -1. So that becomes -3/7. So go and plug in what I have. So I have this 6,561 over 7 minus -3/7, which means I really need to add 3/7. So 65, so let's just see if 6,564, I could divide that by 7. And I can't. So we'll just call that 6,564 divided by 7, and that'd be my final answer there. Again, I have multiple x's, but there's nothing to multiply there. I just need to go and look at add 1, so x to the 4th over 4, minus squared, and then divide by 2. So when I go to rewrite that, I'm going to have x to the 4th over 4 minus 2x squared. And then plug in 1 and -1. So when I plug in 1, I get 1/4 minus 2. And if I plug in -1, I get 1/4 still minus 2. And if I go and do what this says, if I do 1 minus 1, I could simplify that over there, but it's really going to be 1/4 minus 2 minus 1/4 plus 2. Everything is going to cancel out there. So that value is going to be 0. I don't have any area under that curve. They're going to cancel each other out. If I go and look at the next one, tosses me into some sine. I think to myself, integrate 2, that's easy, 2x. If I want to wind up with sine, I would have to start with cosine, right? The cosine of x is normally the sine of x, but it says it wants a positive sign. So I need to go and insert that in before I get started. So my antiderivative, if it didn't ask me to evaluate those two places, would be 2x minus cosine of x plus c. And then again, go and use my values. Pi over 2 and 0. So 2 times pi over 2 minus the cosine at pi over 2. So the 2's are going to cancel. It's going to be pi. The cosine at pi over 2, right? This good guy right there. That'd say I have no cosine fingers. So that means I'm subtracting away 0. F of pi over 2 is just going to be pi. So pi minus, and then if I go and plug in 0, if I plug in 0, I get 0 minus the cosine value at 0. And my cosine value at 0 would be the square root of 4 over 2, which says that value is going to be 1. So I have minus 1. So minus, this value is negative 1. So that really goes and tells me pi plus 1 is my area under my curve. That is my exact area. If you forgot about how to go and evaluate at pi over 2, with these are pretty nice. So as long as your calculator was set in radians, so if I go and hit mode, make sure that I'm in radians, I could just go and type that in. If I type in the cosine of pi divided by 2, there's 0. You could also go into Desmos if you don't have one of these at home, and then just type in what it says. It would also evaluate that for you. If I look at number 4, on this one, again, I have the squared, go and square it. And you should know the trick by now. X squared, x the fourth, I double what the middle would be, so minus 2x squared, and then plus 1. So I want to integrate that. That's going to be add 1, divide by that number. Add 1, divide by that, and then plus x plus c. That is my true antiderivative. And then plug in those two values, 2 and negative 1. So 2 to the 5th power would be 32 over 5, minus 2, so 8, so minus 16 over 3, and then plus 2. And again, just going to go and type that in. I'm going to type in 32 divided by 5, minus 16 divided by 3, and then add 2. And then that is going to tell me that value is 46 over 15. If I plug in negative 1, that's going to be negative 1/5. Plug in negative 1, that's going to make that minus 2, and then plus 1. So again, negative 1/5, minus 2, plus 1. That's going to tell me, it doesn't really matter. That's going to be negative 6/5. So I'm going to be taking 2 minus what happens at negative 1. So that 46 over 15 minus negative 6/5, which means add that. So again, type it in, 46 divided by 15. That'd change it if I typed in the wrong thing. And then plus 6 over 5. Again, math, enter, enter. That's going to take me to 64 over 15. Oh, if I had multiplied that by 3, that would have got me to the same place. If I go and look at the next one. Again, I'm back in some of the trig ones. So if I go and I say, well, my derivative is secant squared, well, what would I have had to start with? I would have had to start with the tangent of x. And the derivative of tangent of x is that secant squared of x. So now go and plug in what I have. So the tangent at pi over 4, that's my sine fingers, so radical 2 over radical 2, or that makes that value simply 1. If I go and plug in 0, and I go and look at what I have, my sine fingers would be 0 over 1. So that's going to go and tell me my tangent value is going to be 0 there. So pi over 4, started freaking out for a second. I was thinking that I was going to get 0 on the bottom and then I was going to mess this all up, but that was not a problem actually. So that value there would be 1. If I go and look at the last one, again, some trig ones. If I go and get the derivative of secant of x, tangent of x, what would I have had to start with? I would have had to start with the secant of x and then plus 2x. And again, if that was my true antiderivative, okay, if that were the indefinite integral, okay, where I don't have a stop and start place, this is my final answer. That's where I would have stopped, okay? And then if I go and look at pi over 3 and 0. So the secant of pi over 3 plus 2 times the pi over 3. So if I go and look at pi over 3, so I got 0 30, which would be pi over 6, 45, 60. So I really want to use. So normally, right, this is my cosine finger. That's the one that's the reciprocal, would be 1/2. Well, the reciprocal of 1/2 says that value is going to be 2. So I have 2 plus 2 pi over 3. And then if I go and plug in 0, the secant at 0. So my cosine value is normally 1. If I flip it, I still get 1. So I have 1 and then plus 2. Or, whoa, if I plug in 0, that would be 2 times 0. So that's just going to be minus 1. And if there had been 2 terms there to subtract, make sure you subtract away both of them. That's why oftentimes I find it simpler just to find out what is that value. Obviously, if it's one that has like a pi and something else, you're going to have to leave it that way. But if you can go and add 2 and 3 together, add them together, and then subtract away 5. So here I can subtract away what I have. Well, 2 minus 1 would be 1 plus 2 pi over 3. Okay. So that's what I would have there. And then we just have a couple more things to finish up. We'll have some homework over using those trig ideas. Keep in mind that when you get into like cosecant and your cosecant cotangents, that's where those negatives come into play. So just be careful with those when you do those. Then we have some review and then your final quiz ever from me. Please don't cry too many tears. But I'm going to try and hold it together because I know that you will miss my quizzes when you go away next year. Hope you guys are doing okay. Have a great rest of your day, night, whatever time you're watching this video. Again, if you need anything, just let me know. I can make another video. I can answer some more questions, whatever you need. Have a great rest of your day. Bye.